All right, thanks. A lot of stuff has happened in Python apparently over the past month or so. So with that, I guess we're going to get right into our talks. This month, we welcome our first presenter who is not either myself or Brian. Our first presenter is Steve Semeniuk, who's going to be giving a talk on test-driven development. It's going to be our more sort of beginner-level oriented talk, so we'll be introducing the idea of test-driven development and why it's a good thing. Oh yes, and you need a different computer for this talk. Yes, so everybody please give Steve a warm, welcoming round of applause.
Perfect timing. Oh. Thank you. Thank you. Try not to overwhelm you with this. I generally don't need a mic, as my children, I'm sure, could tell you. I'm here to talk to you tonight about psychology, cleverly disguised as a test-driven development presentation. I say that because the idea of test-driven development is actually very simple, and I can tell you about it in about 2 minutes. And the challenge is for you to actually accept the idea that it might be a good idea to do. So why don't we dive in? I'll tell you a little bit about me. My mother calls me Steve, and everyone else calls me Steve, so I answer to both. I'm old, and I tell you that for 2 reasons. One, so you'll have sympathy on me when I lose my place about halfway through the presentation. But the other reason is, in the early 80s, I was doing COBOL development, and nobody ever mentioned the words test-driven development or unit testing or formal testing or anything like that. The practice was generally that you just had to be really, 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 really careful when you did stuff. And having experienced both worlds, I can tell you that things are a lot better with formal testing and with test-driven development. I wouldn't want to return, number one, to being a COBOL programmer, and number two, to actually having to go back and write code without that supporting test mechanism behind it. So it's better now. The only good thing about programming in the early 80s was we didn't have to work with Unicode. So this is these are the requisite steps for doing test-driven development. Basically, what you want to do is just kind of get. I mean, number one, you have to have an idea of what you're trying to accomplish and what you're doing. So you write just enough code that you have a clue what you're doing, and then you stop writing code, and then you put on your tester's hat and you start writing your tests, with the full expectation that these tests are largely going to fail. Okay, you get enough of a method signature, you kind of know how things are going, you jump back and forth a little bit, but basically your first job is to write your tests. And then you run them and you watch them fail miserably. But now you have a basis. You have captured your behavior, you know what things are supposed to do. Then you start writing your code. You take off your tester's hat, you put on your developer's hat, you write code until all of your tests pass, and then you're done. Go home, drink beer, you're done. Life is good. Step 4 is something that you can look at only when you've actually completed step 3. So once your tests are all passing, then you can say, fine, I have my behavior captured, I can go and make my code better. So simple. It's simple, but it's just a little bit mind-bending, because if you have never done it before, and even if you have done it before, the whole notion of writing your tests before you write your code is a difficult thing psychologically. It feels wrong. I mean, I don't know what they're teaching in school now. Mind you, I didn't know what they were teaching in school then, because my degree is in math. I never actually studied software. That was just something I did to earn money to pay my way through university. But the good thing about writing your tests is your test first is the fact that it forces you to actually think really hard about your code. And as programmers, we tend to just dive in, we start, well, we want to code right away, let's get to solving that problem. It forces you to identify things that are maybe not well specified or not specified at all. I've run into situations where I've started writing my tests and then I stop. I go, I don't have enough information to write this code. Had I started coding, and I'm sure we've all done it, we start making things up. Well, yeah, it should probably work kind of like this, it should do something like that. If you have to write the test first, it does force you to go through that analysis phase. The other thing it does for you, as I mentioned here, is it forces you to write code that is actually testable. I've run into situations where, when I was learning how to do test-driven development, where I'd start writing a piece of code, get what I think is enough, start writing the test, go back and go, no, I can't structure it this way because I can't test it. It's wrong. So it's a good opportunity. You're not too far into the process. You can stop, reorganize your code to make it testable. The other really difficult psychological piece of it is just accepting the fact that you are adding work for yourself. So instead of just writing your code, you now have a test suite that you have to write and maintain. And double the code, I regularly have 10 times as much test code as I have production code, because I tend to do a lot of database work. And when you get into database fixtures and such, you end up with reams and reams of just, populating the database to a known state so that your tests will actually run. So yeah, it's work. Be prepared for it. It's normal. And it's okay, because you're doing it while your head is still in the problem. If you wait until later, it becomes a lot more expensive to do that kind of testing. So yes, it will add time, but it will add a finite amount of time to your programming process. So, an example that can fit on a PowerPoint slide. Okay, let's forget on my resume that I've actually been working in Python for a while and say that I'm young. Let's pretend I'm young, and let's pretend I haven't done any Python. So I'm a COBOL programmer who's discovered Python and who read a book on test-driven development, and it looks pretty cool. So I was looking through the Python standard library and I noticed, there's no average function. Python could really use an average function. So I'm going to write one. So a couple of things about this. I'm going to write my step 0, which is just enough code to get started. So here we go, I define a function, and I know that average functions typically return a number, so I'm just going to return a number, and the number is 0. Poof, there's version 0 of my code. So now we can write some tests along with it. In this example, I'm using the built-in unit test module. And it's kind of a nice little module. It's based on all the other normal unit test type structures out there. And basically what you do, one thing I want to point out right off the bat is that for even a relatively simple function like average, I chose to make it a function as opposed to just putting the code in line. Why did I do that? Because I can test it. If I put it in line, I can't actually test the code, and I'm not even going to think to test the code. If I put it in a function, I can test it. So I've done that, number 1. So I define a class, subclassing off of unit test case, and I can define methods. And any method that I give with the name of test something or other, the unit test module will just automatically run. So here's kind of what I'm envisioning. I'm going to pass a list of integers, expecting an average out of there. Let's pass some decimals. Let's throw some negative numbers in there. And just for fun, we'll say an empty list should return a 0. Now, I don't know whether these tests are good or bad, but they're there. So I've written some code. I've written some tests. So that was step 1. So now we run them. And of course, I get failures, which was totally expected. Actually, a little disconcerting about this test suite is that everything didn't fail. So that in itself is a problem. But remember, I'm just a young, enthusiastic Python programmer, and I don't know any better. But So I've got a couple of tests in there that are probably not really good tests because they just kind of pass. So I will probably want to expand my test suite, but that would involve making my code larger than a single slide, and we can't do that. So anyhow, I do have some failures, so now I've got some work to do. So now I go on to step 2, and I write the lovely version 1 of the average function. Yes, point and laugh. This is horrible. Although it's not so horrible. I mean, I've seen in mentoring a lot of, back to presenter hat on now. In mentoring new Python developers, I've seen a lot of code like this from people who come from other languages. And it's kind of a normal way that people start writing code, but it is very non-Pythonic. But it works. And let me tell you, there's a lot to be said for working software, because there's a whole lot of software out there in the world that does not, in fact, work. So I've written this software, as horrible as it is, it passes all of my tests. And just for fun, I showed you there's a couple of ways you can run your unit tests. You can run them in terse mode, where you just get dots and an OK at the end, or you can actually get a list of the tests if you run it in verbose mode. And you'll notice it actually throws out the doc strings that I threw into the test methods. So it works. Yay, I'm done. I can go for beer. Life is good. So I'm so happy that I tell all my new friends at the Python group, hey, I wrote this function, call Guido, let's get this put into the Python standard library. And Python people are nice people. They're not going to tell me what an abomination my piece of code is. But what they do say to me is, well, Steve, you might want to look into some of the built-in functions in Python. There are some ways you can make your function a little more efficient. And I think, yeah, okay, fine. Don't need you anyway. So I go away for 6 months and I work on some other stuff. But in the process, I learn some things about Python. And I discover some of the built-ins. And of course I realize, as we all do, when we go back to look at code that we wrote early on in our career, we go, ooh. So in fact, what I want to do at that point, remember I'm 6 months later now, and I look at that code and I go, oh, I've discovered there's some neat things built into Python. I can make this a whole lot more efficient. So I do. Beautiful, isn't it? One-liner. Works on Python built-ins. It's gonna just perform like crazy. It's wonderful. I'm done, right? No. After you refactor, you have to run your test suite again. And what you've just witnessed here is my butt being saved. Because I made what I thought was a really innocuous little change, okay? I cleaned up a bunch of code, I was making it behave exactly as I thought it was before, but I forgot about that little quirk I built into it, where I originally returned 0 and then tested for it, okay? In this version, I'm not dealing with the 0 length list, so the length function obviously throws an exception. So that's what you're seeing here, okay? I can't overemphasize how powerful this is. If you do go through the process of doing test-driven development, these are the aha moments. These are the moments where you go, okay, all of that time I spent working on code, extra test code, this was worth it. This is what made it worth it, because I've now just done this. I mean, this could be, imagine that this is a lot more complex piece of code. It's been out in the wild. It's installed at customer machines. I mean, there's all kinds of bad things that can happen when you do stuff like this. So this is really powerful. So the question is, what do we do now? And you've got 2 options, basically. And the trick is to not try to do both of them. Remember, you either want to decide the behavior is wrong and change the way you're expecting it to behave, or you're going to go change the behavior. But you can't do both. Well, you could, I guess, but it would be bad. So, you may have to go talk to your analysts. You may have to go talk to other programmers who are making use of your function. You may have to, do a whole lot of digging to find out if anybody's relying on that bizarre behavior that accidentally slipped in at the beginning. And if they are relying on it, it may end up being too expensive to change it. So you can take one approach, which is to say, okay, fine, oops, I guess that was a bad idea, but I'm just gonna reproduce the old behavior that was in there and run my tests, and poof, it works. And I've done this before, it's slipped into production and all that, so this is all good. Option B is we go back and we actually change the test. So you'll see here at the bottom, I've gone back to my test empty, and just for fun, just to prove to you that there are things you can assert for other than equality, I actually make sure that it actually raises an exception. So I've talked to all my developers, and they go, no, that would be stupid for an average function to do that. We never relied on that. So we go ahead and we fix it. We fix the behavior. And we run the, so just to prove to you, I'm running the original version 2 of that utilities function. I run the test, everything passes, I'm happy. Beer time. A lot of beer in my software. So I did say at the beginning that this was a psychology presentation, because I'm sure all of this will make sense to you. And my experience with working with developers and mentoring them through this process is that you tell them all this and they go, oh yeah, that sounds great. And then you say, okay, well, start doing it. And they sit down on their desk and they just don't know what to do. They truly don't know what to do. And these are smart people we're talking about. This isn't, people who don't get the concept. They get the concept, they're having trouble convincing themselves. So I invite you to spend some time trying to convince yourself. The graph on the right, I have to admit I stole this from a guy. I stole the idea from him. This was in the olden days when they used to do presentations on overhead projectors, and he was a wild man presenting. The slides were flying all over the place, and he threw up this slide at one point that was just a curve. And he threw it on one way, spun it around a couple of times, flipped it back and forth, and said, this is the graph that can prove anything. And then he got it in the right direction. So this is my graph that can prove anything. So what the graph is trying to show you is, the x-axis is time and the y-axis is the cost of removing a defect, okay? The quicker you can remove the defect in the process, the cheaper it is. Or conversely, the longer you wait to discover it, the more out into the wild it gets, the more expensive it is. So one of the things that you have to convince yourself is, even though you can write your code in 10 minutes, spending 2 hours writing test code, it's only 2 hours, as opposed to waiting the 2 months, letting it get out into the wild, letting your customers discover it, making them crazy. It comes back through QA, they spend a bunch of time on it, reporting it back to you. You have to get your head back into the problem, and it takes you 4 hours to fix it. And then you roll it out and you've wasted all your goodwill, and it's very expensive. So you need to convince yourself how expensive it is. The other nice little side effect is that you can do much more shared development. So you can have multiple developers working on a project, and because you have this test suite available, everybody knows when they've broken something, when they've changed the behavior, when they've done something. So you can actually, the joke we always use around the office is, take 9 women and in 1 month you can have a baby. And that's sort of the analogy holds for software development, throwing extra developers at, I told that really badly, didn't I? Extra developers at a project doesn't always help. Well, test-driven development, or just having the test suite in place, really helps with the ability to throw multiple developers on it. And I guess, the last point is really important. It's going to feel weird. It's okay. It'll feel weird for a while, and then it'll start feeling normal. And finally, you'll get to the point where if you try to write a piece of code without having a test associated with it, that will feel weird. And really, you can get there, because I've been down that path. It's hard to pick just a few resources. My personal favorite is a book by Kent Beck called Test-Driven Development by Example, and it's sort of the, Mike bought it for me a million years ago. And it's a really thin book, as all good books are. It's a really thin book, And it really talks about the psychology of test-driven development and why you want to do it and how it turns programming from a stressful activity into a relatively stress-free activity by introducing these tests. So I highly recommend it. If you want to look further into Python testing capability beyond unit test, PyTest is a really nice module that you can get. The link on here is the video link to Holger's presentation on it. Holger seems like a really smart guy, and I had to stop his presentation multiple times to start looking things up because he just goes really quickly. But it is a good presentation and certainly worth investigating PyTest. The other resources I would recommend are just Google things. And here's a couple of phrases that I Googled that just gave me a whole bunch of links. Some of which are madly in favor of test-driven development, some of which don't like it so much. There's some really interesting discussions. You know, just start Googling and start digging into it. And again, convince yourself of it. And you know, the other little point I guess I would throw out is that you don't have to be a purist about it. You can be a very pragmatic test-driven developer, because there are certain cases where it is less easy to do. It's less straightforward. So, you know, it doesn't have to be a religious thing. You can dabble in it at first. And I'm out of slides. Any questions? Comments? Tomatoes?
I guess a comment, it's easy in a project to decide that going forward, when you submit a function, you'll also submit a test for it. Right? That's just easy to do. Right? Doesn't really
Yeah.
Right. And the legacy code, if you want to go back and write, 1,000 tests, go ahead, but
well, you know, that's interesting that you raised that, the whole notion of legacy code, because at the job I'm at now, I started about a year and a half ago, and I was told to, here, work on these services. So I started poking around. They were written in C#.NET. I'd never done any C#.NET before in my life. It wasn't COBOL. And so, I started asking around, saying, well, do you guys have a test suite for these things? And they all kind of looked at me and went, test suite? And I thought, oh, this is interesting. So nobody really gave me any direction in the job. So I basically spent the first month or so just kind of, not so much sitting down and writing tests, but they asked for some enhancements, they asked for some bug fixes. So I employed what I now, in researching for this presentation, discovered is called test-driven bug fixing, which is basically you start capturing the behavior of the legacy code that you're planning on changing. So at least find out when you're about to break something. Or if somebody reports something that they think is a bug to you, then, capture the behavior, show it failing as a bug, go edit the code, watch the test pass, then at least you know that aspect of it. You haven't hurt. And if you do that enough, lo and behold, if it's an active piece of software, you will in fact have a comprehensive test suite for it, as I do today for this legacy project. So, don't let that discourage you either. Aiden?
Oh, okay. I can go. Could you elaborate a little bit more on what you hinted at, which is that there are some scenarios or types of program where test-driven development doesn't work as well? I'm specifically thinking of something like having to test behavior like a graphical interface. I don't know, I'm sure tools exist, but that seems like a fundamentally harder problem to just create a test. Am I right?
Yeah, I think so. I have to admit, I've always been a back-end guy. I leave the graphical stuff to other people because I started working on 80-column terminals. So I've never had a really good appreciation for that. So for sure, the back end lends itself a whole lot nicer to the whole test-driven model and just testing in general. User interfaces, yeah, there are test tools available for them. I can't offer a lot of expertise in how one might approach that because there is a lot of subjectivity there as well. Somebody looks at it and says, well, it's ugly, but it passes all the tests. Well, it's ugly. So yeah, I mean, as a counterexample to that, I guess I would talk about, you know, one more case out of my own experience where I had a piece of software. It was an object relational mapper actually that hooked up to a Bizarro database that nobody's ever heard of. And when I wrote it originally, I made a performance compromise that I knew was a compromise at the time. But what I did was I decided I'm going to wait for someone to actually complain about it because it was something that saved me a lot of time initially. But I had my complete test suite along with it, and the other developers on the project used it for about 9 months, and then somebody finally hit the performance problem that I knew was going to be coming. So I heard about it. I was like, yeah, okay, fine, I'll deal with it. So I went into my office. I closed the door for about 3 weeks, and I just ripped my code to shreds and rewrote it because I knew I was going to have to do this. And when thought I was close to being done, I reran my test suite. And surprisingly, I think I had about 3 or 4 tests that failed out of 75 or 80 tests. So I was pretty impressed with myself. I thought, yeah, that's good. So I went and I fixed the 3 problems that I had introduced, reran my test suite, and all of a sudden 5 other problems showed up. And this guy's been saved a whole bunch of times. You know, it was really quite astounding. It was actually kind of humorous. I was thinking back to this time. As I changed the code back and forth, I was changing which tests were failing. It was back and forth, till finally I realized, oh, there was something I did that was really just wrong, and I had to rework another small area. But still, it seems to me it was within a couple of days after that, I had the whole suite passing 100%, sent it out to the developers, and they didn't even notice that anything happened, other than things got really fast. So it was a very positive experience. Yes, sir?
When you say you don't change the code and the test at the same time, could you elaborate on that? Like, why not?
It's dangerous. It's a very, very dangerous thing to do. The trick is, the purpose of the tests is to capture the behavior. So if you're changing your behavior and you're changing your documentation of the behavior at the same time, it's a risky thing to do. It's much safer to think of it in terms of hats. I'm testing now, I'm developing now. Because it is entirely possible. You could throw your tests right into your code. I mean, I've seen people do that. I started off doing that too. You just start throwing test code right in your code. But the temptation is there to just start, it's like, this test isn't quite passing, let's just go change the code here. And it's just a good discipline thing to have them in 2 separate areas. You're thinking in 2 separate ways. Again, it's a psychology thing. It really, there's no good technical reason I can give you for that, but psychologically, it's a safer way to do it.
If you were to change the functionality completely, like say you're changing the API, for example, to what you're building, would you go ahead and just rewrite all the tests and add additional tests for new signatures and so on?
Yes, that's exactly what you do. First, document and capture the behavior, then start coding.
Have you found that doing this removes the need for agile development? Or does it work hand in hand with it? It's hard.
Works very nicely with Agile. Yeah, no, it works really well because in an Agile environment, the requirements tend to not necessarily be as well specified as you would hope. So sometimes you end up chasing wild geese and going down a path that you really shouldn't be going down. And the good part about having a test suite along that is it really catches a lot of these things that you know, the behavior has changed. We've introduced a side effect. Very easy to do in an Agile environment. Very nice to have that. The challenge is to get everybody to remember when they're doing their estimating, to remember that there's time for testing. And you know, I still have that in our Scrum meetings where people will say, "Oh yeah, you know, that's a 2," and I go, "Yeah, oh, okay. And how many tests are you going to have to write around that?" "Oh, that's a 5." You know, and it just changes the estimates. But after a while, everybody just gets used to the idea that testing is just a part of the coding process. It's not separate.
agile, whatever philosophies that you can slip into a shop that otherwise isn't ready. Because the ROI is proven, because it's a really pragmatic, it's one of the really pragmatic pieces of the agile toolkit.
Anything else?
It's not.
Great, thanks.